Alright, folks, so today we're talking about similarity transformations. Okay, similarity transformation is a transformation made to a shape to make a new shape that is similar to the original. Then a dilation is a transformation that shrinks or enlarges a figure proportionally, producing a similar figure. We're going to be talking about dilations a lot. Okay. So dilations are performed with respect to a fixed point called the center of dilation. The scale factor of a dilation, we'll talk about that here. It's a ratio of the side of an image to the corresponding side of its pre-image. So it's a ratio of image to pre-image with corresponding sides, of course. So a little definition here, pre-image, that's your original figure. The image, well, that's the new, after we've done the dilation, we produce the image. So in this example, the pre-image is triangle ABC. The image is triangle JKL. So the scale factor, talking about again scale factor here, it's going to be image to pre-image. So corresponding sides, that's JK to AB. Okay. That's just kind of an introduction to dilations here and similarity transformations. There's two types of dilations. A dilation with a scale factor greater than 1 produces an enlargement, okay, or an image that is larger than the original figure. So as we look at this picture here, there has been an enlargement that has gone on. Triangle FGH, which is our pre-image, becomes the image, our triangle RST. Again, the scale factor here would have to be greater than 1. The scale factor has to be greater than 1. So an example of a scale factor, as we write that as a ratio, 6/5, that is greater than 1. Second type of dilation is scale factor between 0 and 1, which produces a reduction, okay, an image that is smaller than the original. So here the original, or the pre-image, would be this trapezoid ABCD, with the image being trapezoid WXYZ. Okay, and again, for it to be a reduction, the scale factor has to be between 0 and 1. An example of that would be 3/4, 1/2, okay, 5/6. Those were all between 0 and 1. So, enlargement, scale factor greater than 1. Reduction, scale factor between 0 and 1. You may want to pause this at times. I've kind of got the notes already written out here, as this is probably my second time recording this. My previous video didn't work, so if you need to pause at any point and make sure you're catching all of these notes, you can surely do so. But we're going to continue. Okay. So here, as we look at example 1, we're trying to determine whether the dilation from A to B is an enlargement or a reduction. Then find the scale factor of the dilation. So, from A to B, what's happening? Well, clearly A is smaller than B. So from A to B, A is being enlarged. This is an enlargement. Okay. Confirm that using the scale factor. Well, we want to compare a corresponding side. So I'm going to use this side here compared to this side here. So A, we found in the pre-image, which is A, we found a length of 3, and the image, the corresponding side here, is 4 units. So its scale factor is 4/3. We do similar work in B. Okay, example B here. We've got triangles though. Okay, well, if we're checking from A to B, well, A is much larger than B, so this must be a reduction from A to B. A was reduced to produce the image B. So the scale factor, again, we match some corresponding sides we see here. These will be easy to count on distance when required. We see this side on B is 2. Corresponding side on A is 6. So the scale factor is 2/6, which we can reduce to 1/3. Okay. As we continue, we look at this example. In the lesson, there's a little note about this movie ticket, and we are wanting to, we want to know by what percent should Ariana enlarge the ticket stub so that the dimensions of its image are 3 times that of the original. What will be the dimensions of the enlarged image? So the pre-image is this ticket. We want it to be 3 times larger. So we're trying to build the image, this new ticket. We take the dimensions of the pre-image, 5 centimeters. We want it to be 3 times that. So we multiply it by 3. And that's 15 centimeters. So the corresponding side down here is 15 centimeters. We can do the same with the bottom here, 6.4 centimeters. We want that to be 3 times as large, so we multiply it by 3, giving us 19.2 centimeters. Got that. Didn't write the 0.2. 19.2 centimeters, which gives us then our dimensions, 15 centimeters by 19.2 centimeters. Okay. We also were asked what percent should this be enlarged by. Well, to change our scale factor of 3 over 1 to a percent, we move the decimal place of 3 to the right twice. Gives us 300%. So this is enlarged by 300%. Okay. So let's continue then. Here we're going to be graphing ABC, which is the original, the pre-image triangle ABC, and then we're going to graph the image, which is XYZ. Okay, we're going to see that it is dilated, and we're going to verify that the dilation is a similarity transformation. So we have to verify that these are similar after taking a look at them. So I've graphed ABC. A was out here at -6, -3, B at 3, 3, C at 3, -3. I graphed that in blue, and then in green I went ahead and graphed the image, triangle XYZ. X was at -4, -2, Y was at 2, 2, and Z was out here at 2, -2. So I graphed them. We can see that it's a dilation, and this would be a reduction, it appears, because the pre-image is, again, larger than the image, so this should be a reduction. So are these similar triangles, we ask? Are these similar triangles? Well, what ways do we have to confirm that? Okay, well, we have angle similarity. We've got side similarity. And we also have side similarity. So we want to use one of these methods to confirm it. We find out that side is going to be the easiest way to do this. Okay. Well, why is side the easiest? If we look inside of the triangle, we've got right angles already. Those are corresponding, and those are congruent. So that gives us the angle piece. Now we just need to make sure that the sides that are included there are proportional. So, well, what sides would we be referring to? AC, which corresponds to XZ, as you can see here. We've got to check that that's proportional. So these sides here. We've got to make sure those are proportional to here. Okay, so that our right angle is included. So that gives us CB to ZY. So we need to check that proportion. As we move, we see we have checked that. Okay, AC over XZ is 9 over 6. CB over ZY is 6 over 4. Both of these are equal to 3/2. So these are proportional sides. Thus, similar triangles by side angle side. Alright, thanks for watching. I'll post the notes key as well in the module, so you have that for you as you work through these. Everybody have a wonderful weekend, and plan on seeing you guys on Monday.